Imagine a place where you could be standing on a scorching hot desert dune, and just a few hundred miles away, climbers are dealing with sub-zero temperatures on some of the world's highest mountains. Well, that place is Pakistan. It's a country literally defined by its climatic extremes. So how can one place contain such a crazy range of environments? In this explainer, we're going to break down the powerful forces that shape this land of, well, fire and ice. So here's how we're going to piece this whole puzzle together. First up, we'll get the basics down just to make sure we're all on the same page. Then we'll get into the twin engines of Pakistan's climate, the story of its temperature, and where all its rain comes from. And finally, we'll see what happens when the whole system gets pushed to its limits, exploring that devastating cycle of floods and droughts. All right, so to really get a grip on these extremes, we have to start with the fundamentals. From the very language we use to the distinct climatic zones that carve up the country. This map right here, it really gets to the heart of the whole question. See those huge yellow and orange areas? Those are the arid zones, the Thar and Karan deserts. But then look north, and you see all the greens and grays of the Hindu Kush and Karakoram ranges, which are some of the wettest and coldest parts of the entire country. This massive difference is the key to understanding how Pakistan can have both terrible droughts and catastrophic floods. Okay, first things first, let's clear something up that trips a lot of people up. Weather versus climate. The easiest way to think about it is this. Weather is what's happening outside your window right now. It's what you get. Climate, on the other hand, is the long-term pattern, the average over, say, 30 years. It's what you expect to get. Simple as that. So Pakistan is basically carved up into 4 totally different climatic zones. Way up north, you've got the highlands, a world of freezing winters and pretty mild summers. Think of it as the country's water tower. Then there are the huge lowland plains, where most of the people live. They get cool winters, but absolutely brutal hot summers, and their lives depend on the monsoon. Along the coast, the sea kind of acts like a giant air conditioner, keeping temperatures from getting too crazy. And then you have the arid zone, these vast deserts where life is just clinging on against scorching heat and almost no rain at all. Okay, so we've got the what and the where. Now, let's dig into the why. What are the real forces at play that make one part of the country blisteringly hot while another is freezing cold? It really just boils down to 4 main things. First is latitude. That's just about how directly the sun's rays are hitting you. Second is altitude, and this one's simple. The higher up you go, the colder it gets. Then you've got cloud cover, which acts like a kind of thermostat for the whole planet. And finally, there's the distance from the sea, which is basically the difference between having a moderate climate and an extreme one. Here's a cool bit of physics for you. Land heats up and cools down way faster than water. So during the day, the land gets hot, the air above it rises, and cooler, heavier air from the sea rushes in to take its place. That's your sea breeze. Then at night, the whole thing flips. The land cools off fast, but the sea stays warm, so the wind blows from the land out to the sea. This daily cycle is exactly why coastal areas don't have those wild temperature swings. Cloud cover is another huge factor. During the day, think of clouds as a giant umbrella, reflecting sunlight back into space and keeping things cool on the ground. But at night, they become a blanket, trapping heat that's rising from the earth and keeping things warm. This explains why deserts, with those clear skies, can be scorching hot by day, but then get freezing cold at night. There's no blanket to keep the heat in. But, temperature is only half the story. The other half is all about water. All right, we've tackled the heat. Now for the other critical piece of the climate puzzle, rain. Where does Pakistan's life-giving and sometimes life-taking water actually come from? The main event, of course, is the monsoon. Every summer, the entire subcontinent heats up like an oven, creating this huge area of low pressure. This thing becomes like a giant natural vacuum, sucking in incredible amounts of moist air from the Indian Ocean. As all this wet air hits the land, it's forced to rise, it cools down, and then it just unleashes these torrential, life-giving rains that define the summer from July to September. But hey, the monsoon isn't the only story here. In the winter, a totally different weather pattern takes over. You have these storm systems called Western depressions, and they travel literally thousands of miles, all the way from the Mediterranean Sea. Now, they aren't as intense as the monsoon, but they deliver absolutely vital winter rain and snow to the northern parts of the country. This is what recharges the glaciers, those frozen reservoirs that feed Pakistan's rivers all year long. And there are 2 other ways rain gets made. In the mountains, you get what's called relief rainfall. That's just when moist air gets pushed up and over a mountain range, so it drops all its rain on one side. Then, on the hot, flat plains, you often get convectional rainfall. The sun just bakes the ground, sending columns of hot, wet air shooting straight up, forming these really intense, localized thunderstorms.
So we have these incredibly powerful systems delivering water. But what happens when they deliver way too much, way too fast? Well, the result is flooding, and it's one of the most persistent and devastating challenges Pakistan faces.
A major flood is almost never caused by just one thing. It's usually a devastating recipe of factors. Just imagine this. A heavier than usual monsoon shows up at the exact same time a heat wave is rapidly melting the northern glaciers. And if that water then rushes down through valleys where all the forests have been cut down and heads towards dams that aren't well maintained, well, you have all the ingredients for a national catastrophe. Now, this is a really crucial point. The immediate human and economic costs of floods are just horrific. We're talking loss of life, destroyed homes, ruined crops, but there's also a surprising long-term positive effect. You see, floodwaters carry millions of tons of this nutrient-rich sediment called alluvial soil. When the waters finally go down, they leave behind this fresh layer of incredibly fertile earth. It's a destructive force, no doubt, but it's also part of this ancient regenerative cycle that has made the plains so productive for centuries. So how on earth do you manage a force this powerful? Well, the strategy has to have multiple layers. It involves big engineering projects like building more dams and stronger riverbanks, but it also means you have to work with nature, replanting forests in the mountains so they can act like a natural sponge and slow the water down. It's not really about stopping the water. It's about managing its journey from the mountains down to the sea. And that brings us to the complete opposite extreme. From the terror of having too much water, we now pivot to the slow, creeping crisis of having way, way too little: drought. You'll notice the causes of drought often look like the mirror image of the causes of floods. It might start with a natural trigger, like a weak monsoon season, but human activity is what really makes it so much worse. Notice deforestation is on the list again. Fewer trees mean the land can't hold on to what little moisture it gets. And bad water management, like leaky canals that waste billions of gallons, can turn a simple dry spell into a full-blown crisis. And a drought, well, it sets off this devastating domino effect. Less water means crops fail and livestock die, which leads to food shortages. Reservoirs dry up, which cripples hydroelectric power plants. The dry soil turns to dust and just blows away, turning fertile land into desert. And all this economic hardship often forces people to leave their homes in the countryside and move to already overcrowded cities just to find work. So, the response to water scarcity is all about smart planning and conservation. It starts with storage, building more dams and reservoirs to capture water in the wet years so you can use it during the dry ones. It's about adapting your agriculture, using modern crops that can actually thrive with less water. And it's about efficiency, simple but critical fixes, like lining canals to stop leaks and planting more trees to help the soil hold on to every single precious drop. Ultimately, the climate of Pakistan is a story of an incredibly delicate balance. It's a dance between the mountains and the monsoons, between way too much water and not nearly enough. And as the world gets warmer, scientists are predicting these extremes will become even more intense. So the central question for Pakistan, and really for all of us, is how will this fragile balance shift? And what is that going to mean for the millions of people whose lives depend entirely on it? Thanks for tuning in.